Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we will discuss on the examples of exact differential equation. You know that exact differential equation means a differential equation which is obtained from its primitive by differentiation only. And I also given the rule for solving the exact differential equation. Rule is integrate those terms in m taking y as constant and then integrate those terms in n which are free from x. Adding these two solutions we get the solution of given equation. That means equate these two solutions, adding them and equal to C. This is solution of given equation. Let us consider first example. In bracket x square minus ay bracket complete dx plus in second bracket y square minus ax bracket complete dy equal to 0. That means this equation is of the form. We have to solve this equation. First write the given equation. Note this as equation 1. This equation is in the form of m dx plus n dy equal to 0. So that here m equal to x square minus ay and n equal to y square minus ax. So that differentiating m partially with respect to y, we get del by m by del by y. With respect to y, x constant, so derivative of x square is 0. And with respect to y, derivative of y is 1, so that minus a into 1, it is minus a. Now we differentiate n with respect to partially with respect to x. Del by n by del by x. With respect to x, y constant, so that derivative of y square is 0 minus derivative of x is 0 minus a into 1. Here both these quantities are equal. That means del by m by del by y equal to del by n by del by x. Hence, you know that if del by m by del by y equal to del by n by del by x, given equation is exact. That means differential equation m dx plus n dy is exact if and only if del by m by del by y equal to del by n by del by x. Now, for the solution, we integrate m dx treating y as constant. M is x square minus ay. Separating terms we get integration x of x square dx minus y is constant, a is constant, taking ay outside the integral. In second integral there is only dx. Integrating these terms we get x cube by 3 minus ay into x. Denote this as number 2. Now we integrating this we get integration of x square. By separating we get integration of x square dx minus ay dx. Integration of x square is x cube by 3 minus ay into x. Denote this as equation 2. Now we have to integrate terms in n which are free from x. Terms in n free from x are y square. Hence, integration of n dy equal to integration of y square with respect to y integration. Here integration terms, integrate those terms in n which are free from x with respect to y. So that here integration of y square dy, and integration of y square dy is y cube by 3. Denote this by 3. Hence, the solution of given equation is, adding this 2 and 3 we get x cube by 3 minus axy plus y cube by 3 equal to c, or after simplifying we get x cube minus 3xy plus y cube equal to 3c, which is equal to c1. This is solution of given equation. That means if given equation is of the form m dx plus n dy equal to 0, write m equal to term, given term, n equal to given term. Differentiate m partially with respect to y, differentiate n partially with respect to x. That means calculate del by m by del by y, calculate del by n by del by x. If these two are equal, then given equation is exact. And if given equation is exact, then we can find solution of this equation by integrating m dx, treating y constant. So that integrate terms in m, taking y as constant. Integrating, we will get one solution. Denote this as number 2. And also integrate those terms in n which are free from x with respect to y, so that you will get one solution. Denote this solution as number 3. Adding these solutions 2 and 3, we get solution as x cube minus 3xy plus y cube equal to c1. After simplifying, we get here solution. You can solve any example in this form. Now we consider next example. Second example is bracket 1 plus 6y square minus 3x square y bracket complete dy equal to in bracket 3xy cube minus x cube bracket complete dx. Let us consider the solution of this equation. We first write given equation in the form m dx plus n dy equal to 0. So that this equation is in bracket 3xy cube minus x cube bracket complete into dx minus in second bracket 1 plus 6y square minus 3x square y into dy equal to 0. So that this equation is in the form m dx plus n dy equal to 0. So that m equal to first bracket, n equal to second bracket with sign. Here sign is negative. Now we differentiate m partially with respect to y, so that del by m by del by y equal to with respect to y x constant, that is 3x constant, derivative of y cube is 3y square, and x is constant, so that derivative is 0. So that here we get 9xy square, and del by n by del by x equal to with respect to x, 1 is constant, derivative 0, with respect to x, y is constant, derivative 0, so that here we get only 6xy. But here del by m by del by y is not equal to del by n by del by x. So that given equation m dx plus n dy is not exact, hence we cannot find solution in this case. Now consider another example. Here given equation is in bracket x raised to 4 minus 2xy square plus y raised to 4 bracket complete into dx plus in second bracket 4xy cube minus 2x square y minus sin y bracket complete dy equal to 0. Let us consider the solution of this equation. Given equation is in the form m dx plus n dy equal to 0. Here m equal to x raised to 4 minus 2xy square plus y raised to 4, and n equal to 4xy cube minus 2x square y minus sin y. Del by m by del by y with respect to y x constant, so that derivative 0 minus with respect to y 2x constant, derivative of y square is 2y, so that we get here minus 4xy plus with respect to y derivative of y raised to 4 is 4y cube, and derivative of n partially with respect to x is del by n by del by x equal to with respect to x 4y cube constant, derivative of x is 1 minus with respect to x 2y constant, and derivative of x square is 2x, so that we get 4xy, so that here we get 4y cube minus 4xy minus with respect to x y constant, derivative of sin y is 0. Here we get del by m by del by y equal to del by n by del by x. Hence, given equation is exact. So that we have to find the solution of this equation. It is find integration of m dx treating y as constant equal to integration of m is x raised to 4 minus 2x y square plus y raised to 4 bracket complete dx treating y as constant, so that we can separate this integral equal to integration of x raised to 4 dx minus 2y square integration of x dx plus y raised to 4 integration of dx, so that we get integration of x raised to 4 is x raised to 5 by 5 minus 2y square as it is integration of x is x square by 2 plus y raised to 4 as it is integration of dx is x. So that finally we get x raised integration of m dx treating y constant equal to x raised to 5 minus 8 to 2 cancels here minus 5x square y square plus 5xy raised to 4 upon 5. Now terms in n free from x are terms in n free from x are minus sin y. Terms in n free from x are minus sin y. Hence integration of n dy equal to integration of minus sin y dy equal to cos y dy denoted as 2. Adding 1 and 2 we get x raised to 5 minus 5x square y square plus 5xy raised to 4 plus upon 5. That means we have to take here 5 cos of y equal to, we can take here constant c, that is 5c equal to some c1 or c. This is the solution of this given equation. That means adding 1 and 2 we get x raised to 5 minus 5x square y square plus 5xy raised to 4 upon 5 plus cos y equal to c. That means after simplifying we get x raised to 5 minus 5x square y square plus 5xy raised to 4 plus 5 cos y equal to 5c. That means c1 is the solution of given equation. That means here we have integrating m dx treating y constant, then we integrate those terms in n which are free from x, adding these two solutions and simplifying we get the final solution of given equation. Now let us consider one definition of integrating factor. Exact differential equation is m dx plus n dy equal to 0. But sometimes this m dx plus n dy equal to 0 is not exact. That means not exact means here del by m by del by y. That means here del by m by del by y is not equal to del by n by del by x. And if this condition is not satisfied, then we cannot solve this equation m dx plus n dy equal to 0. So that then there is a problem how to solve this equation m dx plus n dy equal to 0. So there is a factor known as integrating factor. That means this equation m dx plus n dy equal to 0 will become exact by multiplying it by some factor. That means this equation m dx plus n dy sometimes it is not exact. That means del by m by del by y is not equal to del by n by del by x. But this equation m dx plus n dy equal to 0 will become exact. If we multiply it by some factor. and this factor is known as integrating factor of given equation m dx plus n dy equal to 0. That means if this equation m dx plus n dy is equal to 0 is not exact differential equation, that means del by m by del by y is not equal to del by n by del by x, this equation will become exact by multiplying this equation by some factor. This factor is known as integrating factor of given equation. Thank you.